The isolation valve switch has three positions: close, auto, and open. AC power is required for isolation valve operation. The normal position of the switch is auto. Let's examine the auto position of the switch first. Now touch the isolation valve switch to position it to auto. With the switch in auto, the isolation valve is controlled by the position of the pack switches and engine bleed switches. If both engine bleed switches are on and both pack switches are in auto or high, the isolation valve will be closed. This is the normal in-flight condition. Isolation valve switch in auto, valve closed. This isolates the left and right sides of the pneumatic system so that each engine supplies air to one pack. The APU bleed switch has no effect on isolation valve operation. Now touch the APU bleed switch to turn it off. When the isolation valve switch is in auto, if either one of the engine bleed switches is off or either one of the pack switches is off, the isolation valve automatically opens to connect every user and supplier to the common duct. Now touch the engine 2 bleed switch to close the engine 2 bleed valve. Positioning the APU bleed switch to on electrically arms the valve to open when the APU provides pneumatic pressure. Now touch the APU bleed switch to open the valve. The APU bleed valve is electrically controlled and pneumatically operated. Here we see that the dual bleed light has come on, indicating that once an engine is started, there is a possibility of back pressuring the APU. The dual bleed light itself will be covered later in the lesson. The engine bleed switches control the engine bleed air valves. These valves act as shut-off valves and reverse flow check valves. When the engine bleed switch is positioned to off, the associated bleed air valve closes. By contrast, when the switch is on, that position merely enables the valve to open. Meanwhile, the valve remains spring-loaded to the closed position until air pressure is sufficient to open it. Pressure and temperature sensors monitor engine bleed air. These sensors are internal to the duct. The engine bleed air valves close automatically if bleed air temperature or pressure exceeds predetermined limits. When this happens, the associated bleed trip-off light comes on. Pressing the trip reset switch resets the bleed trip-off light if the fault condition has been corrected. The light will remain on until reset. Beyond resetting the bleed trip-off light, pressing the trip reset switch also enables the valve in question to be reopened if the fault condition has been corrected. Now touch the trip reset switch. The trip reset switch also resets the pack trip-off lights on the pneumatic panel and the duct overheat lights on the air conditioning panel. Note that the trip reset switch does not reset the wing body overheat light, which is discussed next. We've covered over-temperature conditions that are internal to the duct. Now we turn to over-temperature conditions that are external to the duct. Pneumatic duct leaks can cause a wing or body overheat. When sensors detect overheat, the appropriate wing body overheat light comes on. Left and right lights indicate the status of their associated engine mount fairing, wing leading edge, and air conditioning bay. The left wing body overheat light also indicates overheat detected by a sensor in the keel beam and or APU bleed air duct. For the wing body overheat lights, there is no reset switch corresponding to the trip reset for bleed trip off. A wing body overheat light will go off by itself once the overheat condition has been corrected. When pressed, the overheat test switch tests the wing body overheat detector circuits. Now touch the overheat test switch. Pressing this switch should illuminate both of the wing body overheat lights. At the same time, the master caution lights and air conditioning annunciator should also be illuminated by this test. The dual bleed light comes on whenever the APU bleed air valve is open and the position of the engine bleed switches and isolation valve would permit back pressure of the APU. Should the APU check valve fail, it comes on when the APU valve is open and the engine 1 bleed switch is on. It also comes on when the number 2 engine bleed switch is on and the APU bleed air valve is open and the isolation valve is open. Note that the dual bleed light state is based on the isolation valve position, not on the isolation valve switch. Thrust must be limited to idle when the dual bleed light is on. The left pack and right pack switches that control the air conditioning packs are also located on the pneumatic panel. At the top right-hand corner, there is also a switch that controls the recirculation fan. These switches will be covered in the lesson titled Air Conditioning.